Welcome to our webinar with NFU Energy, reducing energy costs on dairy farms, and practical tips and market insights, which will be delivered by, I'm very happy to say, two of my colleagues, Jonathan and Josh. Josh is our Assistant Director and Head of UCM, our Utilities Contract Management department. So he's got some really good insight into the markets and ways that you can benefit and really kind of maximize your profits within your dairy farms. Delighted also to have Jonathan Sendercock with us, a senior project engineer. Here he's going to be some really exciting developments in technology and talk you through some ways to improve energy efficiency on the dairy farms. Now, one thing you might notice is your cameras will be automatically switched off and the mics are off. So if you do have any questions around anything Josh or Jonathan have today to talk you through, please put them in the Q&A chat at the top or just in the chat box, and we will answer questions at the end. So thank you for joining us. My name is Brian McCourt. I am a senior sales consultant here at NFU Energy. And for those of you who aren't familiar with NFU Energy, I'll just give you a little insight into who we are. NFU Energy are a full service energy consultancy and over 58 years experience now in this marketplace. And of course, providing NFU members and non-members with certainly farming and agricultural energy advice, but also to different industry sectors. Also, we specialize in energy management, certainly contracts, which Josh's department can help you with, and energy strategy, renewable energy technologies, which Jonathan is part of that department, which he can help with, and of course compliance around permitting and different technologies around that. So certainly something that we could help you with, whether you are a member of the NFU or you're not currently. So with that, I'm going to hand over to Joshua Robertson, and he'll talk you through the markets and some insight into those. Josh.
Thanks a lot, Brian. So I just want to say firstly, good afternoon to everybody. What I'm going to do is spend the next sort of 10 to 15 minutes just running through a bit about the energy market, what's happened in recent months, and hopefully share some really good insights into what the future looks like on energy as well. So what we've done on this first slide, we've just broken down the energy bill, and I also feel it's really interesting to lead with where the makeup of most people's bills are coming from. So we've heard a lot on the news recently with regards to Strait of Hormuz. I think in the last sort of 6 to 8 months, everybody now understands where it is. If we asked a couple of years ago, that answer would have been very different. But round about 36% of the bill is made up of things that happen in other areas of the world, the general commodity rules. So you would argue in the last sort of 5 to 7 years, you would have had COVID, which would impact commodities. You would have had the Russia invasion of Ukraine. You would have had interconnector fires over in Texas, for example. And most recently, we've had the US invasion of Iran as well. You've then got 2 other areas to the bill. So you've got your renewables. That is a lot of the non-commodity charges, and we will come into these areas a little bit later in a bit more detail, but quite a bit of these sort of levies going forward. It's making up around about 30% of the bill, and these will be historic things like the FIT charge, how customers are paying for historic events that have happened, and why those fall into the bills. So you can see a couple of those in there. So you'll have contracts for difference, nuclear regulated asset base. Every time a new nuclear plant is built or commissioned, that cost and that percentage unfortunately does rise. It falls on a blend of everybody to pay those charges. And then last but not least, we have our delivery section, makes up around about 35% of the bill. And this is the one that's really come to the fore in recent years, largely consisting of the standing charges. But a lot of people in recent years would have heard of CHNUAS charges. And the easiest way to explain those are your big pylons that carry your energy across the UK. There is more work being done on what are known as DUAS charges, which are more local distribution. And then you've also got a big piece around balancing, which is just making sure there's enough import and export to balance the grid and to keep it balanced. So we'll go into each of these areas in a little bit more detail and try and make them as relevant to dairy as we can. Next slide, please, Brian.
Apologies, Josh. The button stopped working again. There you go.
Okay, no worries. So yeah, so the first of those areas are your commodity charges, and what we are seeing is weather patterns are having a recurring theme on charges over the last sort of 3 to 4 years. It's been a big change in that we've either had a year of drought or a year of really bad rain, and either side of the coin, it's I always use a Goldilocks effect with our members when we speak to them. If it's too hot, if it's too cold, that tends to present a problem to the grid, in terms of the grid needing to purchase more energy. In the last sort of 6 to 8 weeks, there have been emergency calls put out there saying that there wasn't enough energy in the country. When you're looking at the sun and you're looking at the effect of solar, I think a lot of people discount how much air conditioning is used and how much that increases the usage across the UK as well. We have seen a continued upwards trajectory in the market. So, like I said, we've had an event pretty much every year over the last 5 years, whether that's been a fire in the US, whether it's been a fire in France, whether it's been war. All of these things are driving the commodity prices. Geopolitics. So, as we've said, these have impacted fertilizer. Apologies about the spelling there because I've just noted it, but fertilizer and diesel prices are almost a byproduct of energy. And when you're seeing one impacted, you're seeing almost three or four impacted in the same way. And then I think there's this global move in the last few years. So historically, if we look 3 or 4 years ago, everything went underwater. So a lot of the gas pipelines flowed from Russia into Germany, and then it went from Germany into most of Europe via what were known as the Nord Stream pipelines. Since those were annexed a couple of years ago, largely, that they moved everything above water. So now you're hearing a lot about tankers. You're probably hearing a lot about shipping tankers being stuck in the Strait of Hormuz. And these are one of the reasons why a lot of that energy that was traveling beneath the sea has just been moved on top of the sea. And with a war again that's targeted those areas where 20% of the energy flows through, it's been quite a big impact on the wider market. So next slide for me, please. So what we've done there is we've just put in sort of the commodity price and the general cost of energy over the best part of 5 years. We're coming up to 5 years now that we've been tracking the energy price every month, to see where those spikes are. So you can see sort of 5 years ago, we were looking at an average floor price of about 18 pence per kilowatt hour. Today, we're sitting in the region of about 23 pence per kilowatt hour, which if that was a straight steady line, we probably wouldn't be having a lot of the conversations we've had, but you can see there are some really big spikes in there. And I would say probably the highest one you can see would have been where the gas pipelines from Russia into Germany were switched off. We capped out the price at 75 pence, and it was only because we tracked that at the start of the month. But within that month, those prices did hit as high as 130 pence per kilowatt hour. You can see, largely speaking, over the last sort of 3 to 4 years, the market had a downwards trend. But if you then went from April 2024, where there were quite a few problems identified, largely with nuclear fleet in France, you've seen the prices start to sort of stabilize out. And then once you got sort of March 2026, you'll see that capping out at 27 pence per kilowatt hour, or just under 28. But again, this is where the Russian invasion of Ukraine, the US invasion of Iran commenced, and you've seen a big jump in the price, albeit nowhere near as bad as it was last time around. So it is a bit of a good sight in hindsight that the market was able to adapt, it was able to change, and when a similar problem occurred, it didn't have as big an impact as it did just a couple of years prior. Next slide for me, please. So in terms of delivery, second of the three areas of the bill, we do have, and it's quite widely known across energy, but the transmission network is quite an old network. Some of these pylons were put up in the 50s and the 60s, and quite frankly, they have reached the end of their useful life. But likewise, we quiz a lot of members, have they ever seen a large scale pylon taken down and replaced? And there is this big drive now. I think it's 80 billion pounds over the next 5 years with regards to looking at the transmission network, getting that energy across the country. Out of the Lincolnshire show earlier this year, we were speaking to members who had been impacted by sort of exploratory drilling on their farms, looking at ways to start bringing that energy in offshore into the grid. We also have the push towards net zero. and basically an increase in green electricity, so increasing that availability. I think especially in the dairy sector, we're hearing more and more with regards to customers needing green renewable contracts. Net zero is a big part of that, but when you're looking at sort of scope 3 and scope 4 emissions, proving the whole journey, we are seeing a real drive, especially in the dairy sector, to have green renewable energy. We then look at another area of delivery, which is the banding of meters. So again, specific to the dairy sector, we've seen the changing of bandings over the last 2 years really have an impact on those standing charges. And we will come on to some of the things that can be done better later on in the call, but the ability to reband the meter into the correct band could see people save money pretty quickly. But it all falls under the delivery element of the bill at the moment. We've had a lot of updates from NESO, or the National Energy Systems Operator. There have been forecasts. There's been already another 23% increase in the first forecasted draft for CHNUOS for next year. So we stay really, really close to that, and we are actually consistently giving feedback into NESO as well. Power moves, as I've said, it is coming across the country now. This £80 billion investment is expected to bring energy to where it's needed most in the UK. And then we're looking over the next 5 years, where can we see some real changes? Where can we look at infrastructure changes or challenge the grid on some of what they're doing and make it a little bit easier to understand? Next slide for me, please. So what I've done is I've just gone to a little bit more detail there. You'll see the orange section, which largely captures a lot of dairy farms. But you can see just around the orange section, you've got a blue section, which is the LV, or your low voltage meters. You can see there the average spend which we've put in is normally anywhere from £0 to £3 a day in terms of your standing charge on your first 3 of those bands. If you're a band 4 meter, which most dairy farms will use more than 27,000 units, which is just in your threshold column, you would generally see that that standing charge could now be as high as £6 a day. Now, every supplier does bill differently. We have about 41 different suppliers on our books, and we have some that still do a 0 standing charge, albeit with a higher unit rate. And then we have other ones that have a high standing charge and a lower unit rate. So it's always good to sort of compare. And this is where I say increasingly going forward, it's really important that the sums are being done and they're being worked out correctly, because a 0 standing charge on a high user isn't always the best thing possible. That second section, which is sort of the lighter orange colour, you can see our low voltage meters, which are small half-hourly meters. Now, a lot of dairy farms do sit within this section, and you can see your bands there. The difference between being in band 1 paying £6 to £12 a day standing charge, and band 4, which could range from £35 to £56 a day standing charge, it really does show the importance of understanding the capacity of the meter, the ability to shift between bands, and the ability to do the right thing to make sure you're placed within the best band for you. I won't go into any of the other ones, because your purple ones and your TCS bands, they sort of verge into the millions of pounds a year, and there are very few dairy farms that would ever enter anywhere near those. But if you can move on to the next slide for me, please. Yeah, so when we look at some of the specifics to dairy, we do look at sort of a general benchmark. So the benchmark in energy for dairy has been 1 kilowatt per cow per day. And that is generally how we would calculate average usage. Now, there are some caveats to that, where you're looking at sort of robot milkers, where you're looking at 3 times a day versus 2 times a day. We do see some differences there, but the general benchmark is each cow would use 1 kilowatt per day. That has been reviewed on averages in the past, but what we have seen, as I said earlier, when we looked at commodities, the hotter weather in recent years has seen a bigger strain on energy equipment, and as such, we've seen some of those bills increase. Some of the usages have increased over the last few years. Specific to dairy, we are looking at sort of what's known as a time of use tariff. It's something that we're really, really excited about, because what we're seeing very often is between 3:30 and 5:30 in the morning, we're looking at sort of the grid format and how much energy is available on the grid, and we're seeing some days there's 85%, 90% availability between those times of day. Generally speaking, that's when dairy farmers are starting to utilize their energy, and the question is increasingly being asked of the grid, why is their price not much cheaper at that time of day than it would be otherwise? On an economy 7 meter, which most dairy farms will have, you'll have a flat price between midnight and 7 a.m. But some of our work at the moment has sort of factored out that a price between sort of half three and half five should be about 8 to 10 pence a kilowatt hour, which is some 50–60% cheaper than what it's being charged at the moment. It does have its caveats, because as the rest of the UK wakes up between half six and eight, that energy price would actually spike a bit. And this is where sort of your batteries will come to the fore in the years to come. We are looking at a profile class as a bit of a unique profile class. There are very few profiles in the sector and also in the wider industry that use energy at unconventional hours. And this is why we are sort of keen to trial this time of use tariff within the dairy sector first. Just my bottom point there, smart metering is a key requirement for any of these new changes for the future of how energy suppliers are going to bill you. A smart meter is almost mandatory. If you don't have one and the supplier can't get your data at a 30-minute interval, it's not impossible for them to put you onto any of these trials and to bring these things forward for you. Next slide for me, please. Yep. So we do look at renewables. We look at the continuity of the renewable scheme. So we've got the sort of first people that installed FIT was about 2003. We're going to expect to start seeing people fall off that scheme in 2028. Now, that will remove some of the non-commodity charges that I spoke about earlier, albeit it's a very small percentage. And what you're removing on one hand, you're seeing increases on another hand. So it doesn't always lead to a net fall in price. The expectation from the grid is you won't see that equalising or falling of prices until about 2031, albeit it's still open to a lot of conversation. Technology and the mix is becoming increasingly important, so we are seeing more and more members looking at solar options, looking at wind options, and increasingly looking at battery. And I think the really interesting thing with battery going forward is going to be the ability to bypass the energy when it's needed most by the grid. So there are two sort of key capture zones, 6:30 till 8:30 in the morning and 4 till 7 p.m, where people do have battery. What you'll likely see in the years to come is people will be shifting over to their battery usage at those peak hours, recharging in the middle of the day when there's a lot of energy available on the grid. And as such, even if they're put on a time of use tariff, they're able to bypass the biggest spikes in the grid. We've also seen a lot happening recently with appeals to the DNO. So there have been some changes behind the scenes with people able to change capacity, but not enough to satisfy the DNO or the district network operator. So when we're talking about those, we're talking about likes of National Grid, Scottish Power Networks. We are seeing a bit of a relaxation with some of them, whereby if you can give back 20, 30, 40 kVA back to the grid, even if it's not the 50% change that they originally asked for, there are some of those DNOs that are a little bit more open to having that conversation and still taking the capacity back. But again, that can be very locational, and it's quite important to sort of have that conversation with the DNO first, which we can always do for you. And then, as I've spoken about time of use, we'll just touch on it again slightly, but the grid versus the usage pattern. In terms of renewables and what they're doing, solar is great, tends to be in the middle of the day, 12 till 4. Wind captures it really, really nice either side, first thing in the morning, early evening. And then you do have a few technologies which naturally run 24/7. So the importance to the grid going forward is the technologies that can give back to the grid when the grid needs it most will eventually be worth more to the grid. So it gives a bit of insights, and I know Jonathan will come on to that in a little bit more detail later on. Next slide for me. So what we've done here is we've just looked at sort of your average oil price and how that's impacted your energy price. So you can see a little bit of a similarity, albeit it's not as bad as it was expected to be first time around. So when we looked at it back to sort of the 16th of February, we were already getting murmurs in-house with regards to Trump and Iran having these conversations. We started tracking it really, really early. So your average oil price was $72 a barrel. Your average unit price was about 19 pence per kilowatt hour. Up until the sort of 1st of July, we sort of fixed out a unit price of about 22 pence per kilowatt hour, and your oil price was coming back down to just under $70 a barrel. However, you can see the big swing in the oil price hitting a high of $115 a barrel, whereas your unit price on energy only really ever capped out at sort of just over 24.5 pence. So we did see some similarities, but not enough to say it's a major concern. And that's largely because of the time of year that it happened in. If that war and that situation had happened early in winter, we would have likely seen a much bigger swing. And there are still some pretty big concerns around the winter to come as to how much storage we can get into the UK ahead of the winter. So if you head on to the next slide for me. Yep. So in terms of a brighter outlook, what can we see going forward? So there's a lot of investment in LNG terminals. So again, the ability to store energy is increasingly important as the years go by. It tends to be nowadays that there's always a war or there's something that's happening somewhere around the world that impacts our energy. So the ability to store more of it is quite important. There is a lot more pressure being placed on the National Energy Systems Operator. So just recently, there was another sort of request sent out to give feedback on why renewable technologies are being handicapped. NFU Energy are actually sending quite a lot of information back to the likes of NESO, the likes of Ofgem on some of those areas as well. There have been some changes. So in October 2025, there was a change within the EU, and that limited the requirement to guarantee 90% storage. So in terms of a rule book, the UK and every other country in wider Europe and within the EU should actually be at 90% storage capacity by the 1st of November. That's largely being relaxed a little bit because there are such big concerns about the availability of oil at the moment. There were exemptions passed that said it doesn't need to happen. Previously, that would have needed to be 80% by the 1st of November. So yeah, it got a little bit stricter, and then the EU were able to relax that quite a bit. Norway, interestingly, have also been given a relaxation and exemption on the essential maintenance in their gas fields, which then allows them to kind of keep supplying energy into wider Europe as well. And as I've talked about already a couple of times now, time of use, we are currently working alongside 3 key suppliers. There's a real focus in dairy there, and we're hopeful of a trial early next year. It could be towards the end of this year, but I don't want to make any promises too early. Next slide for me, please, Brian. So yeah, so in terms of outlooks as well, there are a few interesting pieces sort of behind the scenes. So we won't go into this too much, and we can always share the slides on request if required. But I think a real interesting one, which we're awaiting authority decision on, is that 466. So you can see there's a little bit of red writing, one from the bottom. And what this is, it's basically the ability for customers to shift through those bands a lot easier than what they could have done before. So I'll give a really quick example, but if you had a 200 kVA meter, the only way that you could actually shift out of a band would be to give half of that capacity back to the grid. Now, in reality, giving half of the capacity back means that the site can't function effectively, or you're at risk of increased blackouts, for example. So there has been, and NFU Energy do sit on the panel, but there has been best part of this 5-month consultation, which has looked at all of the barriers that presents and all of the reasons why it doesn't give the grid what they want long term. We are pretty hopeful that by the 1st of September, we'll see some real relaxations in that rule, which will again allow people to just give 10 kVA back to the grid and be able to shift out of band 2 to band 1, for example. Where our biggest customers have made savings on that in the past, they've been able to shift through a band, and moving from band 4 to band 2 saves them an average of about £13,000 a year just on their standing charge. And we already have cases where we've successfully done that. So we are really excited for some of these changes that look like they're coming in. But yeah, like I said, there's a lot that we could go through there, and I'm quite time bound, so we can always catch up on those later or pop something in the Q&A if there's a question on those. If you just want to move on to the next slide for me, Brian. Yeah, in terms of sort of landscape going forward. So yeah, these are just some of the quick changes that we could look at going forward that might support as well. So I suppose the first one is on-site generation. What you're using yourself, it tends to be more valuable than what you sell back to the grid. So secure your supply routes early and then reduce your reliance on the network as much as possible. What you're self-using, you're generally getting it back at the full price. What you're selling it back to the grid, it's normally about a quarter of the price that you would buy it at. So we always say use as much as you can. Energy contracts versus storage. So what can you control? So where you've got basically good roof space, there are abilities and there are ways that you can now private wire that energy around the same site. So it might not necessarily be the dairy farm that has the ability to take the energy, but a private wire to take it to the farm itself could actually see you just shift that energy sort of just down the lane or just across the road and still utilize it at its maximum price and potential. Increasingly, suppliers are becoming aware of the markets, and you would argue a couple of years ago, every contract you took was a fixed contract and it wasn't going to be reopened. In the last 18 months, we would argue that probably 95% of all suppliers in the UK have reopened their energy contracts, despite them saying they were fixed contracts. What we're now seeing an increased amount of members doing is looking at what are known as flex contracts, which remove the risk up front because suppliers tend to bake in their profit and risk anyway. So we are seeing a bit of a change into the dynamic of what type of contract is the best option for a customer. So there is a lot of conversation around there and a lot of things to look into. License exempt supply. So there are some rules at the moment, sort of behind the scenes, whereby if you're generating, giving energy back to the grid, you can claim exemptions on certain parts of your standing charge. It's pretty complex and not one I can discuss in a minute or two, but always happy to have conversations around that. And then we're looking at the increased battle on import versus export. So where customers are exporting back to the grid, there are some niches whereby if you have the same supplier for both sides of the fence, you actually get paid more for your export than say, for example, you had one supplier, supplier A for your import and supplier B for your export. So again, it's about looking at the niches, something NFU Energy can definitely help with, looking at partnering up the import and export to maximise as much as possible on both sides. Banding, as I've talked about, is really important to make sure you're in the right band and paying the appropriate amount to begin with. And then just that clarity on the future of energy. So I suppose smart meters really would be a key one going forward. Next slide for me, Brian. So yeah, so this one, I think we've already spoken about it quite a bit, but for any of those on the talk at the moment, if you're with British Gas currently, we would strongly advise that you do just sort of go onto Google, have a look at an option called Peak Save, which is currently giving energy away free of charge on a 6-week trial basis. It's up to £100 a session, and they do that on Wednesdays between 12 and 4 p.m. So they're already starting to put in the sort of the trial options and having a look at how this impacts the grid. But again, it's one that we can always converse on a lot more if required. And then I think last slide for me. Yeah, so yeah, overview from myself really, and it is one that we sort of try and use in-house, but the farms that succeed over the next decade will not necessarily be those that use the least energy. It will likely be those that manage it the smartest. So again, this is where we do say things like batteries will come to the fore. It's about sort of being invested in what's happening on the grid, or looking at somebody that can support you with that journey. And I would argue that's definitely something we can help you with. So I think that's all from me. I think I'm
Absolutely right,
handing back to
Joshua.
Brian.
Thank you for that. Some really, really good insight within that, particularly for me anyway. The time of use is going to be really exciting for next year. Getting those tariffs right and help our dairy farmers maximise their energy bills, of course, and clarity on what's in those bills and what they're made up of, but also the bandings, quite a good insight, but some really good stuff in there, Josh. Thank you. Now I'm going to hand over to my colleague, Jonathan Sundercock, our Senior Project Engineer. He's going to talk about some energy efficiencies that can really help you on the dairy farm.
Brilliant. Thank you very much. Good afternoon, everyone. Yes, so through this part of the presentation, I just want to look at some of the most practical opportunities for reducing energy costs on dairy farms. There's a lot we could cover, but the focus today is on the areas likely to have the greatest impact, understanding where energy is being used, improving the main dairy systems, and then making renewable generation work more effectively for the farm. There are three main messages I'd like, hopefully, for you to take away. The first is to measure and understand your energy before investing. Second is to focus on the systems responsible for most of the farm's electricity consumption. On many dairy farms, these are typically vacuum pumping systems, milk cooling, and water heating. They often account for up to 80% of the farm's total electricity bill. And third is to reduce the underlying demand before deciding how much renewable generation or storage you're going to need to help offset your consumption. So I believe that sequence is incredibly important, is to understand first, reduce consumption second, and then generate the remainder after that. Next slide, please. A useful principle is that when we measure and understand something, it becomes much easier to control. Electricity bills tell us how much the whole farm has used, but they rarely tell us why. Two farms with a similar herd size and milk output can have very different electricity consumption profiles because of differences in equipment, controls, milking times, maintenance, working practices. Even relatively simple monitoring can begin to separate the dairy into its main systems and show where the greatest opportunities sit. The objective is not to collect data for its own sake, it's to turn data into decisions. This example on the screen shows how total electricity use can be separated into system-specific comparison. Here specifically showing vacuum pumps, water heating, refrigeration. The important point is the largest load will not always be the one the farmer expects. And on some farms, water heating is dominant. On others, it could be refrigeration, or it could be oversized vacuum pumps. Once the main loads are separated, we can then benchmark them, investigate abnormal consumption and prioritize investments based on actual evidence. This is much more reliable than selecting technologies simply because they are widely promoted. A good starting point is an equipment inventory. List the main motors, heaters, compressors, and pumps, along with their rated power and approximate operating hours. Going a step beyond this, where possible, installing temporary submetering that can confirm their actual consumption in the form of CT clamps and online cloud data storage. This chart was generated using CT clamps and online data storage, and it shows the monthly use of these individual dairy systems. It allows us to compare equipment directly and identify which items merit closer attention. It can also reveal whether equipment is operating outside the hours that we expect. Next slide, please. On this example, it shows a positive reason why monitoring can quickly pay for itself. On this particular farm, the farmer anticipated that his ice builder was generating ice on his overnight cheap electricity rate, his economy 7 tariff from midnight till 7 a.m. What we quickly found, as you can see from the blue line here, is that the ice builder time control had not been set correctly. So the refrigeration system was actually not kicking in until about 5 a.m. in the morning. This was right at the end of his season, so he'd proceeded for an entire milking season with an incorrectly set timer for his ice builder. Identifying this earlier could have resulted in significant energy cost savings by just simply reverting the time switch through simple maintenance. So the solution was neither expensive nor technically complicated. It was just to change the time clock and would have quickly paid for the cost of the monitoring equipment, having identified this several months earlier. These opportunities are easily missed on the main electricity meter because the overall bill still looks reasonably plausible. Timers, thermostats, and control settings should therefore be checked regularly, particularly following power cuts or seasonal changes or maintenance work carried out on the parlour, and daily load profiles give another layer of information. Using this particular profile, we can sort of see the typical morning and evening peaks that we typically see with a twice-a-day milking parlour. It helps us understand not only how much electricity is consumed, but when it is consumed. This becomes particularly important when considering time of use tariffs that Josh discussed earlier, or introducing things like solar PV, whether or not batteries would be suitable, or other thermal storage options. A farm may have a good annual solar generation, but if the main load occurs early in the morning and late in the evening, such as this example, the financial benefit may be limited unless some demand can be shifted into those middle hours of the day. Next slide, please. Although every farm is different, as we discussed, approximately 80% of dairy electricity commonly sits within 3 areas. These are the vacuum milk pump system, the refrigeration system, and the water heating system. These are therefore the first systems I would investigate on most conventional dairy farms. Lighting and smaller equipment still matter, but the largest savings are normally found within these 3 processes. Next slide, please. Starting with vacuum pumps, the main opportunity is matching pump output to actual parlour demand. A conventional fixed speed pump is normally sized for peak airflow. However, that peak demand may only occur briefly during an entire milking session, such as when all the clusters are attached, or when there is an air admission event, or during the washing process. For most of the milking, the pump may produce much more airflow than is actually required at its full output. A regulator then controls the vacuum by allowing air back into the system. In simple terms, the farm pays to create surplus vacuum and then dispose of it. A variable speed drive changes that. Pressure sensor will allow the pump to slow down during normal operation and accelerate only when additional airflow is genuinely needed. This can produce substantial savings in vacuum pump electricity. Where a pump is being replaced, a roots or rotary low blower style pump can be particularly well suited to VSD operations because it generally has a wider usable speed range, allowing for more turn down in certain circumstances. Also, compared with an oil lubricated rotary vane pump, a low blower also removes the need for continuous sealing oil within the pumping chamber. That can mean less oil handling, less mess, and a cleaner plant room. However, the key point is that VSDs will deliver energy savings, whether they're retrofitted onto existing pumps or if they're installed as part of a complete pump replacement. The low pump just provides a strong platform for maximizing these savings. This particular chart here was taken from a study whereby a fixed speed 3.8 kilowatt motor was retrofitted with a variable speed drive. The average energy consumption across a milking session was significantly lowered to just 1.7 kilowatts, a 54% reduction in energy consumption. That won't always be the case for many parlours, but you would typically expect to see 20 to 30% energy savings on most systems. Next slide, please. Variable speed can also benefit the milk transfer pump, but for different reasons. A traditional on-off milk pump may send milk through the plate cooler in short, high-flow bursts. The cooling water flow does not necessarily modulate at the same time as this, and this reduces the water-to-milk ratio through the heat exchanger and can reduce cooling performance. A level-controlled variable speed milk pump moves the same volume of milk more steadily through the plate cooler. This gives the cooling water more opportunity to remove heat and can reduce the milk temperature entering the bulk tank. The refrigeration compressor therefore has less work to do. The main benefit should not be measured only through the electricity use of the milk pump motor. It should also be measured through the milk temperature after the plate cooler and the subsequent reduction in refrigeration consumption. A reduction of about 2 degrees Celsius by retrofitting the variable speed drive to the milk pump could result in about a 12.5% reduction in refrigeration energy requirement. The plate cooler itself also needs sufficient water flow, clean plates, and a suitable water inlet temperature. So it's worth keeping note of your system and trying to optimize it where possible. Next slide, please. Refrigeration compressor technology is another area to consider when equipment is approaching replacement. Older reciprocating compressors use pistons, valves, and stop-start compression process. Modern scroll compressors use 2 interleaving scrolls to provide a smoother and more continuous compression process. As a general guide, upgrading an older reciprocating compressor to a correctly selected modern scroll compressor may reduce electricity demand by around 15 to 20%. Higher savings may be possible where the whole refrigeration package is upgraded, including the condenser, expansion valve, and controls. However, maintenance can be just as important as compressor type. A dirty condenser or poor ventilation, incorrect refrigerant charge, or badly configured controls can significantly reduce the efficiency of either technology. Next slide, please. The refrigeration system removes a large quantity of heat from milk. Typically, this is then just exhausted to atmosphere. A heat recovery unit can capture part of the heat that is being exhausted and use this to preheat water used for washing purposes. This reduces the electricity required from immersion heaters or electric boilers. The example shown compares two farms and indicates a 34% reduction in water heating electricity demand where heat recovery was used. However, commissioning is critical. There can be a temptation to set recovered water target temperature too high. As the target temperature rises, the refrigeration system has to operate at a more demanding condition and can lose efficiency. So whilst you're gaining in reducing your water heating energy consumption, you may inadvertently be increasing your refrigeration energy consumption. I would suggest a typical target temperature to be anywhere from 30 to 40 degrees, much higher than this, and you may then start not having any energy benefit having installed the system. Heat recovery should normally provide useful preheated water with the final temperature left provided by the main water heaters themselves. Next slide, please. Milk source heat pumps is an emerging technology, and it takes this idea further by combining milk cooling and high temperature water production into one integrated system. The system removes heat from the milk and upgrades it to produce water at more than 90 degrees Celsius, while also cooling milk to 2 to 3 degrees Celsius, dropping it directly into the bulk tank, ready just to be kept maintained at that low temperature. In principle, one system can replace an ice builder or glycol chiller, along with an electric water heaters and traditional heat recovery units. Early installations have reported promising electricity savings, and the level investment may be comparable with a sizable solar PV system. The important caveat is that performance must be compared against the correct baseline. If the existing farm has inefficient cooling and no heat recovery, the apparent saving may be very large. If that farm already has effective plate pre-cooling, efficient direct expansion cooling, heat recovery, and well-controlled hot water storage, the additional saving may be more modest. However, several farms that were considered efficient have still achieved reasonable electricity savings. It's therefore a promising whole system replacement option. Next slide, please. This slide shows the systems that a milk source heat pump may replace. The attraction is not simply that it's a more efficient water heater or a more efficient chiller, it is the integration of the two processes that already occur together, cooling milk and producing cleaning water. The system generates plenty of cheap hot water, allowing for extra hot washes if desired. If you're only doing one hot wash a day, you could easily accommodate doing 2 hot washes a day. And potentially there could be enough heat available to link into other uses such as district heating in nearby buildings. The business case is strongest where is the consistent milk volume, a significant hot water demand, and existing equipment due for replacement. The chart here shows a real-world example of a farm that installed and could compare from 1 year, from the previous year to the year with the new equipment. And as we can see, there were significant energy savings to be had. The red line here represents the new system monthly consumption with the milk source heat pump, compared with the blue lines, which was the conventional system. Next slide, please. This is another case study that shows why conventional efficiency measures discussed here should not be overlooked. This particular farm we visited didn't really have any energy efficiency improvement equipment installed. The farm then installed a variable speed drive on their vacuum pump and added a conventional heat recovery system. The measured reduction was approximately 1,475 kilowatt hours per month. The electricity value used in the example, this produced savings of around £4,400 per year and reduced the total electricity bill by approximately 20%. The farm was also lucky enough to secure grant support, meaning its own investment was less than £5,000 in this case, making for an extremely quick return on investment. The monthly comparison demonstrates that the saving was not simply a short-term test result. Energy consumption was consistently lower following the improvements. For any project, this type of before and after verification is important, Savings should be measured rather than assumed from a supplier's headline percentage. Next slide, please. Once underlying consumption has been reduced, we can consider renewable generation. On-farm renewables can offset imported electricity, provide access to lower cost energy, and potentially generate export revenue. However, annual generation is only part of the story. The value depends heavily on whether the electricity used on the farm at the time it is generated. Next slide, please. Solar PV is normally the easiest renewable technology to deploy on a dairy farm. We have large roof spaces available, typically that don't require planning permission, and the cost barrier is relatively low. Many farms have suitable adjacent land as well, if the roofs are no longer suitable to accommodate a ground-mounted system. The challenge is the timing. A conventional twice-a-day dairy often has its largest demand during the morning and evening milkings, while solar output peaks around the middle of the day. A solar system may therefore export a large portion of its generation unless the farm adapts how and when certain loads operate. This is why the demand profile should be analysed before finalising the PV system size. Next slide, please. In this case study, the top left chart indicates the yellow bars of solar generation that was used on farm, and the red bars was excess solar generation that was exported to the grid. In this example, only around 40% of the solar electricity was used by the farm, and this reduced the overall grid reliance by 17% of the farm's total electricity consumption, with the remaining being exported. The model was then adjusted by shifting an energy-intensive cooling process and water heating into the middle of the day using thermal storage options. Solar utilisation increased to approximately 70%, and the total farm offset improved to 32%. This was done with equipment that was already readily available on farm. The main lesson is that matching demand to generation can be just as important as the size of the solar installation itself. Next slide, please. There are several ways to shift energy demand. The simplest option is often a time clock, water heating, ice production if you have an ice builder, slurry pumping, or other flexible loads can be scheduled for periods of low electricity prices or high solar generation. Thermal storage can be particularly cost effective because dairy farms already need the hot water and the cooling. A well-insulated hot water tank stores energy for later use, and 1,000 litres of hot water can store up to 90 kilowatt hours worth of heat energy. Ice Builder stores the cooling that can be later used during milking. Alternatively, lithium-ion battery storage can absorb electricity and is a more flexible solution, but it's generally the most expensive per unit of useful storage. The important caution is that thermal and electrical storage are not directly equivalent. Emerging technologies such as the milk source heat pump directly compete with other thermal storage options, therefore diminishing their value as energy storage mediums. Meanwhile, energy stored in batteries, as mentioned, is far more flexible because it can be used for any processes on the dairy farm. Batteries are also constantly dropping in price, with new battery chemistry set to transform the market over the next 5 years with new, cheaper materials such as sodium-ion batteries, where weight is less of an issue for static storage and the chemicals used are far more abundant. Next slide, please. Micro anaerobic digestion is another opportunity we are seeing successfully deployed on UK dairy farms. AD produces biogas from slurry and other organic materials. That gas fuel can then be, the gas can fuel a combined heat and power engine, producing electricity and useful heat at the same time. A wider benefit is that AD can also reduce methane emissions from slurry storage and improve manure management and enhance the value of your slurry in terms of an organic natural fertilizer. However, it's not necessarily suitable for every dairy farm. A slurry-only system needs a reliable supply of fresh manure throughout the year. Therefore, housing setups are particularly important because slurry deposited at pasture can't be collected and used in the system. Also, sand bedding can create serious operational problems unless effective separation and grit removal systems are installed, which can add a significant capital cost to the overall system. Instead, it may be more suitable to consider alternative bedding materials that are more sympathetic to the AD systems, such as sawdust. Imported feedstocks can improve gas yield, but they also add transport, permitting, contamination, and contract risks. Slurry-only systems should be able to generate more than enough energy for most dairy farms, and therefore I would tend to encourage sticking to that. AD should be viewed as a combined manure management and energy project, not simply as another electricity generator. It has far more widespread benefits for the farming process. Next slide, please. So just to finish quickly, I hope I've got the message across for the 3 key stages I would encourage every farm to follow, which is first to understand your energy consumption, use bills, equipment inventories, submetering, regular reviews to establish where energy is being used and when. Secondly, reduce gross consumption, prioritize the vacuum pump, the refrigeration and water heating systems, check controls and maintenance before committing to major capital expenditure, and verify savings after installation. And then third, become more energy independent. As mentioned, solar PV is often the simplest starting point, but its value improves when you adapt loads to match the times of generation. Thermal storage, batteries, AD and milk source heat pumps may all have a role, but their suitability depends heavily on the farm's demand profile, housing systems, existing equipment and operational capacity. The overall message is simple. Measure first, improve efficiency second, and then size renewables around the reduced and better understood demand. That's all from me, but I just wanted to comment one final note. I hope this has provided some useful ideas of where to begin, and equally importantly, where a little more investigation may be needed before investing. And for the larger half-hourly customers, linking back to something that Josh spoke about on capacity banding earlier, if you are on the cusp of a certain electricity band, some of these energy saving opportunities may tip the balance, allowing you to sneak into the lower band, which could lead to a beneficial reduction of several £1,000s a year in standing charges. That's everything from me.
Thank you, Jonathan. That was brilliant. Again, some excellent information and advice with some real world case studies, giving tangible evidence on what's possible. And of course, all of the team at NFU Energy are here to assist in identifying all of these technologies. And as Jonathan mentioned very early on there, measuring and reviewing before you invest is key. And energy audits with feasibility reports on any technology can be done by Jonathan and the team here. So really good insight there, Jonathan. Thank you. And of course, some opportunities don't have to cost a lot of money when using data or identifying where you can make efficiencies. You can it doesn't have to cost a lot getting the timers right and things. And milk source heat pumps, who knew? And I know that Jonathan has some good experience with that. So thank you, Jonathan. A great presentation there. So what are the next steps? Of course, understanding what your energy consumption is, and trying to lower that with the help of the team here, and become more energy independent. Taking control of the energy on site and how you're using it and how you're controlling it is absolutely key. And of course, everybody here at NFU Energy is committed to helping you manage that and get it under control and save you some money. We know that milk prices are down and fuel costs are up, and maximizing profits is key. So please get in touch with us after this session if you wish to really get into how you're going to maximize those profits with help from ourselves. This presentation or webinar will be shared with you. You can review it later at your leisure if you wish, or share it with colleagues or anyone else that you care to do that. If you've seen some things in here that really interest you and you'd like to investigate some more, I know it's been a really good one, this. Thank you, Josh and Jonathan. I'm going to have a look now for some questions in the chat there. So thank you everybody who has tuned in and logged in. I know time is precious. So let's have a look at the chat to see what kind of questions we've got. Okay, from Bridget Well, is there equipment to allow power be turned on only if renewable source is in surplus, so that timer will allow only top up on cheap electric? Jonathan, I think that's over to you.
Yeah, there certainly are. They're called power diverting relays. They're quite commonplace in sort of the domestic solar sector, where they'll get installed on solar systems linked to hot water cylinders. So have the exact same use case as on a dairy farm. Those can be installed typically for less than £1,000. However, what I would sort of say is, whilst they are a useful piece of equipment to have installed, you want to independently assess your contracts. For example, if you are importing energy from the grid at about 26 pence per kilowatt hour, 25 pence per kilowatt hour, and you end up with a really favourable export contract of about 15 pence per kilowatt hour, which is currently available on the market, by selling the energy to the grid for 15 pence versus buying it in, there's only a 10 pence difference. Therefore, you'd actually be better off selling that to the grid for revenue rather than installing a piece of equipment to divert into your water heater. It would be a balance of how you would make a return on investment of that £1,000 that you spent installing that equipment, if the gap between import and export was larger than that. So it is a useful piece of equipment. However, depending on your contracts, it may not be value for money at this time. But that's certainly something that we can discuss at what point it could become value for money.
And of course, Josh mentioned earlier in his part that, of course, we're looking at the new time of use contracts with suppliers, so that can also assist with that type of thing. So what about getting the data logging equipment to measure the energy that each process is using, and what is the appropriate spec? Jonathan, I think there's one for you too.
Yes, so I mean, we have energy logging partners that we conversate with and have available that we can certainly put you in touch with. Otherwise, speaking to your local electricians, they should be quite familiar with individual circuit-based energy monitoring equipment. Typically, I'd sort of try and recommend sticking to class 1 accuracy meters. They're not the top spec meters, but they are far and away accurate enough for these purposes, and it ensures that you will just get the correct readings through your system, and you'll also be able to review things such as power factor to see how clean the power come to your farm is, and to ensure that you're not losing any efficiency in that way as well. In terms of output, these kind of systems will be able to probably drill right down into measuring data every 5 seconds. Of course, that may be a little bit too granular, but sort of setting up a regime where you can review consumption every 15 minutes or so should be a reasonable step forward. And something that has a easy to use online platform so that you can at a glance review your data is extremely valuable.
Perfect. Thank you, Jonathan. And again, thank you, Josh and Jonathan, for some great insight there. It's been really beneficial for myself, and I've learned some things too, and I hope all of you who have logged in today and joined us have really took some real positive advice and information away. If there's absolutely anything energy related or specific things that are within this presentation that you wish to discuss with us, please get in touch with us here at NFU Energy. We'll be more than happy to help you, and thank you again for joining us today.